Hi, this is Team 8. We made a project on sentiment analysis of social media trends, and we've used semantic web technologies to provide structure to the unstructured data and then do sentiment analysis. So, this project basically uses YouTube, Twitter, and Flickr to get the trending data. Then we use RDF and ontologies to provide structure to that unstructured data. We make use of the Alchemy API to generate entities, keywords, and sentiment from that data. And once we have the entire data, we use it to show the user how the sentiment is being populated, which are the entities contributing to that sentiment. And all of this is made possible by the use of structured data. So just to give you a quick demo of how the app works. So the front end is just a presentation layer where we are just showing the data that we get. There's no logic on the front end. The entire logic sits at the back end. So when you come on the front end screen, you get a button saying get sentiment. So when you click on it, a call is made to the APIs and we get the data, we perform sentiment analysis, and we generate the RDF. So like you see now, the social media trends are positive at this moment. Now when the user clicks on get details, they'll get a detail about the entities that are contributing to that sentiment. So these are all the entities like you can see. So you have Los Angeles, OJ Simpson, and then there's this hashtag from Twitter that says Premier's Twitter Awards 2015, another hashtag, so on and so forth. So all of this data is coming from either YouTube, Twitter, or Flickr. We are not making any rankings, so none of the social media gets any preference over the other. The next thing that the user can do is see details about the particular trending data. So for example, we have Los Angeles and it has a positive sentiment. So when we click on see more, we get the details of Los Angeles. So some of this detail comes from the social media source. The rest of the details we are querying DBpedia for it. So for example, you can see the entity name is Los Angeles. There's this description. This entire description comes from DBpedia. There's this image and then thumbnail. So all of this is actual data. So if the user selects the data and wants to view it, they can do that. So this is what we get for Los Angeles, and all of this data is coming from DBpedia. So we also show the source for that link. So that comes here in the link data source. So if the user wants, they can go and see the data here. So this is the entire DBpedia source that we are querying. This has a lot of triplets here, but we're using the most common ones that are returned with almost every other source. And there's other information here. So the website. So we got this trending data from YouTube. So one of the YouTube videos might have had Los Angeles in their title or their description, and we got that from here. Its sentiment is positive like we had seen. So now to talk a little bit about the backend. So the backend was entirely made in Spring. To run the service, you just need to execute the Spring command, and when the service is up, we have provided a REST URL that basically calculates the sentiment. So when I make a call to that sentiment, you can see here that it's making calls. So now this is all the YouTube data, and then this is the data that we get from Alchemy. And now all these queries that we are seeing, these are all the queries that are made to DBpedia. So now that it has all stopped, it means our RDF has generated with the instance data. And this is the RDF. So you can see there's a lot of data. So you have source from Flickr, then you have source from you have Ellen DeGeneres. This is the link data source for this particular entity. Then this is all the data. This has come from YouTube, all these RDF types. So like you can see, this is a very big RDF instance. And the way our logic works is we have kept everything modular. So when you hit the service again, you can add more and more to this RDF, and it keeps building up. Now for the sakes of performance, we have just limited it to a particular single instance here, because at one given time we get about 50-60 instances returned. So we are not showing multiple results because that'll affect the performance. So for now, it's just a single call that gets all of this data, and it's up. When you run it, you're pretty much able to see all the DBpedia Sparkle queries that we're executing, what is the result that is being returned. You can also, if you go really to the top, you can also see the data that's being returned from Alchemy, YouTube, Twitter, Flickr. So you can basically, like, this is able to get data from all of the various social media sources that we have considered, bring them together as one, do analysis on it, and then show the details about it. And all of this is easy to do because of the structured format that we get, thanks to the semantic web technologies. So that's all. Thank you.